Problem 16. There are 8 basketball teams, and each team plays every other team twice, home and away, and each team also plays 4 games against non-conference opponents. So if we choose one of the 8 teams, that's 8 choices, and then there are 7 left for us to choose the other team to play with. So that's 8 multiplied 7. And the order of the 2 teams that are chosen do not matter, so we divide 2. And because every 2 teams play twice, so we multiply 2. And plus, each team play 4 games against non-conference opponents, so that's 8 multiplied 4. So it equals 56 plus 32 equals 88 games in total. Because George walks 1 mile to school every day and with a steady speed of 3 miles per hour, he arrives at school just as school begins, so the time he walks to school will be 1 mile divided 3 miles per hour. And today he was distracted and walked for the first half mile at a speed of 2 miles per hour, so the time took for him to walk the half mile would be 1/2 divided 2. And the typical time is 1/3, so we use 1/3 to subtract the time he walked today for the half miles. That's how much time that is left for him to arrive at school. And there is 1/2 mile distance left. We use that distance to divide the time, that is the speed he needs to run. So we simplify this. It's 1/2, 1/3 in the denominator, subtract 1/4. That's 1/2 over 1/12, and that equals 6 miles per hour. The answer is B. Problem 18. Let's first calculate how many girls and boys combinations are there in total, because within the 4 children, each of them can be either girls or boys, so the total combinations would be 4 to the power of 2, that equals 16. And for choice A, there is only one situation that all 4s are boys, so that's 1 out of 16. And for choice B, similarly, there is one choice that the 4 children are all girls, so that's also one choice out of the 16 choices. And for choice C, 2 are girls and 2 are boys. That is equivalent to we choose 2 children from the 4 that are girls. So choose 2 from 4. It equals 4 multiply 3 divide 2 factorial. That equals 6 total choices. So 6 over 16 equals 3/8. So that's larger than A and B. And now let's look at D. We choose 3 are of one gender and 1 is of the other gender. That's like choose 1 of the 4 children to be either girls or boys. For girl, we have choose 1 from the 4 children. We have 4 choices. And similarly for boys, for 1 boy, we also have 4 choices. So that's 8 choices in total. And 8 divided 16 equals 1/2. So out of the first four answers, answer D has the largest possibility to occur, so it's most likely to happen. The answer is D. Problem 19. Let's draw the cube. So it's constructed with 27 cubes. Each surface will have 3 by 3 1-inch surfaces. Now we can see that the center cube will not display any of its surface outside. Therefore, if we want the white surface to show as less as possible, then one of the white colored cube should be in the center. So that leaves us with 6 subtract 1 equals 5 white cubes to be placed on the surface area. So in order for the 5 white colored cubes to show as less surface as possible, we should put them on the center of each surface, white. So because there are 6 surfaces in total, so we can put 5 of them with white cubes, and the other will be red. So if we count the surface area, then 5 square inch surfaces will be white, and the total surface will be, for each big surface, it's 3 by 3, that's 9 square inches, multiply the 6 surfaces for the big cube. So that's 5 out of 54. The answer is A. Problem 20. Let's calculate the radius of the 3 circles. RA, we know that it's 1, and RB equals AB subtract RA, that's 3 minus 1 equals 2, and RC equals CD equals 3. So the area within the rectangle and outside the circles will be the area S equals SABCD subtract 1/4 of the combined area of the circles. That's R1 square plus RA square plus RB square plus RC square multiply pi. And the area of ABCD is 5 multiply 3 subtract 1/4, 1 square plus 2 square plus 3 square pi. And that equals 15 subtract 3.5 pi, and it's approximately 4. The answer is B.